So in this video, we're going to talk about how to divide polynomials by factoring. So what we can do is we can rewrite division as a fraction. So for example, if we have 24 divided by 16, we can rewrite that as 24 over 16. So we can do something similar with polynomial division. For example, x squared plus 5x plus 6 divided by x plus 2 can be rewritten as x squared plus 5x plus 6 over x plus 2. So you may be wondering why we're doing this. The advantage of doing this is that you can identify and cancel common factors. So this gives you another way to divide if you don't want to use long division. So for example, when we write 24 over 16, we can rewrite 24 as 8 times 3, and we can rewrite 16 as 8 times 2. Well, then notice they have a common factor of 8 that we can go ahead and cancel, so that gives us 3 over 2. So we've basically divided 24 by 16 by rewriting it as a fraction and then reducing that fraction. So similarly with polynomials, if we have x squared plus 5x plus 6, we can factor it as x plus 2 times x plus 3. And then we have that x plus 2, which is our divisor. And then notice that this common factor of x plus 2 will cancel, which gives us x plus 3. So this is a way to divide when you have polynomials that can be factored. So we'll start off by rewriting the division as a fraction, make the dividend the numerator and the divisor the denominator. Then factor everything as much as possible, cancel common factors, and then the remaining expression will be the quotient. So let's try this example. So if I rewrite this as a fraction, I have 4x cubed minus 5x squared minus 6x over x minus 2. So let's first now factor the numerator. So we have 4x cubed minus 5x squared minus 6x. And notice that these terms have a GCF. The GCF I can factor out is x. So I'm going to factor an x out of every term. So that means I'm going to have 4x cubed over x minus 5x squared over x minus 6x over x. So when I simplify that, I have x times 4, and then x cubed over x to the 1 is x squared, minus, and then I have 5, x squared over x to the 1 is just x, and then minus 6, and then x over x will just cancel out. Okay, so now I have a trinomial where a is not equal to 1, so I have a is 4, b is negative 5, and c is negative 6. So a times c equals 4 times negative 6, which is negative 24. So now we need to think about how to factor this. So we need factors of negative 24 that are going to add to negative 5. So let's list out the factors of 24. So we have 1 and 24, and we have 2 and 12. And let's see, we now have 3 and 8, and finally we have 4 and 6. So let's think about the signs. So we have negative 24, so we need a positive and a negative factor. 5 is negative, so I'm going to make the bigger factor negative. So I'm going to go through and make all of these negative. So 1 plus negative 24 is negative 23. 2 plus negative 12 is negative 10. 3 plus negative 8 is negative 5. 4 plus negative 6 is negative 2. So 3 and negative 8 are the correct combination. So let's expand out this trinomial. So we have 4x squared plus 3x minus 8x minus 6. Now let's put the terms into two groups. So we have 4x squared plus 3x plus, and then we have negative 8x minus 6. So let's factor out from the first set an x. And so we have 4x squared over x plus 3x over x. And then that's going to simplify. We have x times 4x squared over x is going to be 4x, plus 3x over x is going to be 3. From the second set, we can factor out a 2. And let's see, since that's a negative 8x, we're going to go ahead and factor out a negative. So that's going to be negative 2. And so we have minus 6 over negative 2. And then that plus negative 2, I'm going to make that a minus 2. And then negative 8x over negative 2 is going to be 4x. Minus 6 over negative 2 is going to be plus 3. So notice that we have a common binomial of 4x plus 3 that we can factor out. And then we write the terms that are left on the outside, so we have x minus 2. Remember that we had a GCF in the first place, so we're going to go ahead and add that back in. So that's the fully factored form of the numerator. The denominator cannot be factored, so now let's rewrite that fraction we have in factored form. So we have x times 4x plus 3 times x minus 2 over x minus 2. And notice now that this common factor of x minus 2 will cancel. So we're just left with x times 4x plus 3. And that is now our final answer. So now you can go ahead and pause the video and try doing this example on your own. So once again, we rewrite this as a fraction. So we have x cubed plus x squared minus 12x over x plus 4. And then notice that the numerator has a GCF of x that we can factor out. Then we're left with x squared plus x minus 12. So we need two factors of negative 12 that are going to add up to b, which is 1 in this case. Negative 3 and 4 are the pair that works. So we have x, our GCF, times x minus 3 times x plus 4. So when you plug this back into that original fraction, notice that the common factor of x plus 4 will cancel. So if you're dividing two polynomials that can be factored, division by factoring is an alternative to using long division. Rewrite the division as a fraction and then cancel common factors.